today what we're going to be talking about is we're going to be talking about this new word called isotopes. And what an isotope describes is it's a word that we use to describe atoms of the same element, but they have a different number of neutrons. So I want you to think about what we've been doing at the beginning of the semester. We've been looking at a piece of matter, and we've been breaking that matter up into its individual atoms, and now looking at one individual atom. There are millions and billions of atoms in here, and if we were to break them up, then we could look at one individual atom and find out about it. So far, we've learned that every single one of those atoms has two parts to it. An inside part that we call the nucleus, and an outside part that we call the electron cloud. Now, this substance right here happens to be called an element, because if we were to break this up into its individual atoms, all the atoms will look the same. They all look the same. So it's called an element. If we took water and did that, not the same. H2O. So we'd have two different piles of atoms. It's called a compound. Same thing as salt. NaCl. A compound. Two different elements. But this guy happens to be only one element, carbon. Now what we've talked about so far is we've talked about two of the particles inside that atom. We've talked about the inside called the nucleus. And there was one particle that we've been writing about inside the nucleus, and that was the number of protons. Excellent. The number of protons inside the nucleus. And we've been talking about the outside, which we call the electron cloud. Excellent. And that's what our sentence has said. A certain number of protons in the nucleus, a certain number of electrons outside the nucleus in the electron cloud. So we've only talked about two types of particles, and we've been ignoring the third particle in the atom. Today what we're going to be talking about is that third particle and what that does to the atom. That third particle is called the neutron. The neutron. Isotopes, atoms of the same element. So we're dealing with atoms of the same element. So if I take this element, break it up into its individual atoms, I'm looking at atoms of the same element. But they have a different number of neutrons. So before we write all over this and get all these notes, what I'm going to do is I'm going to introduce it looking at the drawings that we've been doing, and then apply those drawings to these notes over here. Okay? So first thing we're going to do is take a look at back here. I've got three atoms set up. Here's the first atom. Here's the second atom. Here's the third atom. What I want you to know is this atom has 6 protons in the nucleus and 6 electrons arranged outside the nucleus. The reason we say it's arranged is because there's different energy levels those electrons are at. This one has 6 protons in the nucleus and 6 electrons arranged outside the nucleus. This one has 6 protons in the nucleus and 6 electrons arranged outside the nucleus. And so now, the last particle that we need to talk about, are the neutrons. If you look at your diagram, you will notice that the neutrons should fall on the inside or the outside of the atom. They should fall on the inside of the atom, which we call the nucleus. What I'm going to do is I'm going to use the color green to indicate the neutrons. This is a carbon atom, this is a carbon atom, and this is a carbon atom. That substance, that matter that I was holding over there, if I broke it apart into its individual atoms, we could look at this atom, we could look at this atom, we could look at this atom. But it can be that these atoms, even though they have the same number of protons, and even though they have the same number of electrons, it can be that they have a different number of neutrons. And so this carbon atom can have 1, 2, 3, 4, 5, 6 neutrons. So here's a carbon atom that has 6 protons, 6 electrons, and this one happens to have 6 neutrons. But this carbon atom, 6 protons, 6 electrons, this one may have 1, 2, 3, 4, 5, 6, 7 neutrons. It's still carbon, it just has a different number of neutrons. And this carbon atom, maybe it has 1, 2, 3, 4, 5, 6, 7, 8 neutrons. Carbon atom, carbon atom, carbon atom. 6 protons, 6 electrons, 6 protons, 6 electrons, 6 protons, 6 electrons. But, and when you compare these atoms, they have a different number of neutrons. This one has 6 neutrons, this one has 7 neutrons, this one has 8 neutrons. They are all carbon atoms with the same number of protons, same number of electrons, but they each have a different number of neutrons in the nucleus. The word that we use to describe that is isotopes. Isotopes are the same type of atom with a different number of neutrons. So, when I write in our R2, how do you find the number of the neutrons? The number is not always going to be the same. It can be different depending on which atom you're looking at. The number for neutrons, I have to write something that will indicate that it may be different. It's not always going to be the same. And so what I'm going to do here, the number, I'm going to write the word, varies. Alright, so I have to put a number that's going to indicate that it's not always going to be the same. And so the word that I use is varies. It may be different for each atom. And the way we're going to find that is we're going to write in parentheses mass number subtract atomic number. And we're going to learn all about what that mass number means shortly. It varies. It can change. It's not always going to be the same. It varies. But the way we're going to find it is by taking the mass number and subtracting away the atomic number. Good question. We don't know what the mass number is yet. I haven't talked about that. When we get down here to the notes, I will put the mass number there. Okay? So, the charge on a neutron. Proton, the word proton begins with a P. That helps me remember that protons have a positive charge. Electrons are negatively charged. Neutron, just like its name sounds, it is neutral. Neutral. It has no charge on it. It has no charge on it. Neutral. And the mass of a neutron. We haven't taken any notes on this yet, but since we're here, we're going to go ahead and put this in. 1 atomic mass unit. We will go back later and talk about what an atomic mass unit means. For right now, just because we're here and I don't want to forget to put it down later, we'll go ahead and put it in. Sometimes they will abbreviate that as a capital A, a capital M, and a capital U. 1 AMU. All right, now we have to have a way to describe, not only in a symbol form, but also a name form, each of those types of atoms. So what I'm going to do is I'm going to go back over here. You're not going to write this down. You're just going to watch. And we're going to figure out how we're going to write the name of each of those atoms and how we're going to write the symbol of each of those atoms.